Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Heat and Gravitational Photon Energy. Now, as I detailed in Article 336, Stellar Nebula Cloud Structure, photon energy can exist in three forms: as a free electron traveling at the speed of light, as mass, and as photon energy inside a particle. The last form is photon energy, which is contained within particles with mass. Furthermore, stars have nebula clouds of ions and electrons, which are fed by the stellar wind they produce. The electrons increase in energy the further they are from the star. In this way, these electron clouds are like the energy levels of an atom. And here we see how the structure of these nebula clouds, which I showed in Article 336. And the orange circles represent the nebula ion clouds, and the blue circles represent the electron clouds. Now, the gravitational energy of the electrons in the electron clouds increase as we move outwards away from the sun. And the gravitational energy in the form of mass of the ions in the nebula clouds increases as we move closer to the sun. So it increases inwards. Now, the same structure that we see here, it is actually the same structure as in atoms, where the most massive part is in the nucleus, and electrons have higher energies as we move further outwards from the nucleus. Planets also have radiation belts called the Van Allen belts in the case of Earth, which are actually analogous to the Sun's nebula clouds, but seem to be populated by particles coming from the solar wind. All celestial objects operate like atoms and are thus like superatoms. Now, particles come out of photons when these move through a region of high enough electric field. And at that time, the photon energy turns into the mass of the particles, and the rest continues to exist as gravitational energy inside the particles. This gravitational energy determines the strength of the gravitational interaction between the two. And it causes protons and electrons to be separate from each other, to move apart, because it causes these two particles to repel each other. So there's a repelling force between the two. The gravitational interaction between protons and electrons is a repelling interaction. But this means that atoms can form. What we have here is an hydrogen atom. It contains a proton in its nucleus, and there's an electron outside the nucleus, orbiting the nucleus. Now, there are two forces then that act on these particles. There's the gravitational interaction that will cause the electron to move away from the proton, and there's the electrostatic interaction, which causes the electron to be attracted to the proton. And these two forces, when in balance, create the hydrogen atom. But when there is not enough gravitational energy inside the particles, then the gravitational interaction is not strong enough to overcome the electrostatic interaction, and the hydrogen atom would collapse into a neutron. So the electron and the proton come together and form a neutron. And the same thing occurs in all atoms, no matter how many protons they have in the nucleus. So this is a lithium atom that would contain 4 protons in the nucleus and 3 electrons outside the nucleus. When it absorbs a photon, then this electron would tend to move away from the nucleus because the gravitational interaction becomes stronger. So it will be more strongly repelled by the protons in the nucleus. And we can see here the two forces again. These are the two forces that keep the electrons trapped in a region outside the nucleus. One force pulls it inwards, that's the electrostatic, the other one pulls it outwards. When these forces are in balance, so that the electron just simply is attracted to a certain extent, but is not pulled in towards the nucleus so that the atom collapses, then it's just trapped in a region outside the nucleus. Now, stars are atoms on the macroscopic scale. Electrons can absorb photons, which, as I said, carry gravitational energy, which thus increases the strength of the gravitational repulsion between the electrons and the nucleus, which may then result in the electrons leaving the atom or moving further away from the nucleus. But electrons can only have certain specific energies within an atom. So in order for an atom to move from one energy level to another, it needs to absorb a photon with a specific wavelength, which corresponds to the difference in the energy between the two energy levels. Thus, in order for a photon to be absorbed by an atom as gravitational energy, it has to have specific energies or wavelengths. However, any photon, when incident on matter, will lead to an increase in its temperature. An increase in temperature is associated to an increase in heat energy, which is associated with an increase in kinetic energy. In other words, the absorption of photons leads to a particle moving faster or vibrating faster. Thus, when photon energy is incident on an atom, which does not correspond to the specific energy which will allow electrons to shift energy levels, this energy is absorbed as heat and not gravitational energy. This therefore shows that photon energy, which can be contained within particles, is in two different forms: heat photon energy and gravitational photon energy. The reason why there are only specific allowed energy levels which correspond to only certain allowed orbits seems to be because photons are waves as well as particles, and since all particles come from photons, all particles are also waves, and thus all particles have a characteristic wavelength which must fit into the circumference of the orbit of that particle. So this would be the wavelength. It has to fit exactly, so that when we are trying to put it together end to end, wherever we have if it ends at a crest, then we must put it together with the crest of a wave. And if we increase the circumference of the orbit, so it moves to a higher orbit, and this wavelength doesn't fit on that orbit, so crest comes to crest, then that orbit is not allowed. And this is what's shown here. As you can see, this orbit cannot be fitted here, so this orbit would not be allowed in a certain atom. Since celestial objects operate like superatoms, it is likely that planets also can only occupy certain orbits in a star system, and that gravitational energy is quantized differently for each star system. So in conclusion, photon energy, which exists within particles, can be in two forms: heat and gravitational photon energy. In order for a photon to turn into gravitational energy, it must have certain specific wavelengths which are characteristic of a specific atom and depend on the position of the atom's energy levels. Photon energy not at these specific wavelengths turns into heat energy. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.